really unique about this time is the opportunity to see the solar corona, the atmosphere of the sun, during the entire time of the eclipse stitched together for 1.5 hours. And the sun, of course, is important because it's the most important star. Everything we learn about other stars we learn here first, but it's also a source of weather and radiation. And actually on board this aircraft we have 2 instruments, one from Los Alamos and one from Space Environment Technologies, that make those very measurements of how this radiation affects us.
Yeah, and I think it's important. The more we know about the sun, the more we know about space weather, it'll help us protect our own spacecraft in the future. It'll also help us protect our astronauts as we send crew further, and our home planet in terms of what's going on here. So why don't you tell me what you think we're going to see today and what we're going to learn today through this just incredible event.
So one of the most amazing parts of this is really to see the star as a magnetic star. And what I'm showing here is actually a prediction of the space environment of the sun today by predictive sciences and 3D printed by applied physics lab. And it basically shows that these magnetic fields are there. And what's really going to be great today is we're able to test these models using observations from the ground that we normally don't have. And so this is really exciting for us.
Very good. We've got over 11 spacecraft and over 50 balloons going up. We've got airborne science like we're even doing here. On the G3, can you explain what we expect to get out of the spectrograph we're going to have here on the plane today?
So a spectrograph is basically taking the light of the sun, which is white, and spreads it into its colors. And what we're going to see is during the time of now and partial totality, we basically see during the partial eclipse, we see the radiation from the surface of the sun, the photosphere, and all colors are there. Well, when we're in total eclipse, what we're going to see is the radiation from the atmosphere that we normally really don't see that up close. And that radiation actually has 2 predominant lines. One is a really hot iron, and the other one is, it's hot because it's 1,000,000 degrees because of that magnetic field. The other one is helium, called helium because of Helios, the sun in Greek. So it was actually discovered during an eclipse, just like it today.
Very cool. So here we are about 30 minutes away from totality. But you can explain to me what you think from a spectrograph perspective. You're going to look out the window. What are you going to see there?
Well, so for me, the amazing part really is that we're able to, of course, see our star in its beauty. And I'm already kind of emotionally touched even now. But also, we're going to see how that eclipse, that the lack of radiation, this perfect cloud that the moon makes, affects the Earth and its turbulence. I'm really going to see whether we're going to feel it up here.
Very cool. All right, thanks, Thomas, and thanks for sharing everybody out there. I tell you, about 30 minutes away, we're going to measure as much as we can here, and I'm about to fight this man for a window seat. So when you get on an airplane and you look for a window seat, get your glasses on. We're going to look out here, and we're going to wrap up here from the G3 and send it back to Solar Eclipse Central. See you guys soon.
Wow.
And that's great.
Amazing, yeah.
Thank you to those of you on the G3 to fill us in on what you're going to be seeing from there. Here we are on the other side of the country, here at Charleston, South Carolina. I want to give a shout out to the college. The students here have been so incredibly great for us. And we are actually going to have a chance to go back to Salem, Oregon and find out a little bit more about what they are seeing there. They're talking about this moon picture right here.
Right, we've got a live picture right now from Salem, Oregon. We were showing you earlier in the broadcast, and as you can see, as we've been sort of describing it as the moon taking a bite out of the sun, it's continuing to happen. And what it looks like, Karen, is like it's almost like the sun. What we see is almost like a crescent moon, but it's not. It's the moon is actually the black portion in the upper right-hand portion of the sun that's being blocked out as we get closer and closer toward totality, which, as Robert and Thomas said from the G3 aircraft, is only about 30 minutes away for folks in Oregon.
And we will go right to Madras, which is right near Oregon. This is another view of the eclipse. One of the great things about this particular eclipse, Sean, right, is that the totality will be over land for so long. So we're about to start seeing it in Oregon, but normally, most times when you have an eclipse, a lot of it happens over the ocean, right? The ocean gets to see it.
Right. So for folks, especially here in the United States, this is the first time from coast to coast that we've seen a total solar eclipse since 1979. And so that's why for a lot of folks, we're talking about this being a once-in-a-lifetime opportunity. And remember, it takes about 90 minutes for the totality portion of the eclipse to cross the United States, the continental United States. So as I mentioned earlier from the G3, about 30 minutes from now to totality there, about 90 minutes to get to where we are here in Charleston. So that means what? If I'm time's right, in about 2 hours, we'll be at totality here.
And we are now going to go to Salem, Oregon, where Jesse Carpenter will be talking to Nikki Weil, a solar scientist from NASA.
Welcome back to Salem, Oregon. It is clear, but yes, it is a little bit breezy
It's
here
windy,
today.
yeah.
Isn't it? Yeah. I'm joined again with NASA solar physicist Nicolene Weil.
Hi.
Hey, so why don't we just take a look at what we've got going on here now that transit is deep underway.
Yeah, so the moon is crossing in front of the sun, and it's kind of looking like the moon is taking a bite out of the sun. And if you guys have any colanders with you, like a kitchen colander strainer, you can actually see, if you let the sunlight come through that colander and look at the shadow on the ground below you, you'll actually be able to see the projected image of the moon taking a bite out of the sun down on the ground in front of you.
Oh, that's cool.
Yeah.
So you can just get something from the kitchen and share that with everyone who you're watching this with. That's great.
That's right. Now's the time to take out your pinhole cameras if you have those, or if you have those, the safety eclipse glasses. Now's the time to get these out and make sure to look at the sun with these on.
That's right. You want to be watching safely. And I know we've been talking about it, but we really can't stress it enough. It's very important to be wearing these glasses.
It's just so amazing, though, to see the moon crossing in front of the sun. I mean, you never get to see anything like this.
So, are there some basics that you could share with us? I know we were trying to present some of that a little bit earlier in the show.
Yeah.
But are there some things that maybe you could talk a little bit about the layers of the sun?
Yeah. So